Hello and welcome to today's webinar. My name is David Cash. I'm a member of the marketing team here at Mountz. And I'm glad that you have taken the time to join us today as we look at our topic of how to improve torque control with in-process monitoring. And so anytime we're talking about being able to collect data, especially these days with the Industry 4.0, the Internet of Things, and the advent and surgence of MES systems, now is a really good time for us to be able to implement that and to be able to use that information to help us in our process and through our assemblies. Now, if you've been through any type of lean manufacturing training, this is going to look very familiar. We have our dotted line, which is our capacity, which if the production is working correctly, everything is moving through the production as it should be with the correct timing and moving along the process. Now we can see that this is nothing, or this does not typically happen, but we do have peaks and valleys within that production run. And this is an example of what we can look at as far as data is concerned to see how we can move these peaks and valleys closer to the capacity line. And so everything above the line is Murray or overburdened or overworked. And this can be from equipment that does not have the capacity to handle the load that is being used for. And then everything below the line would be muda or our waste. And that could be typically waste of transportation. It could be waste of time. It could be waste from rework or scrap. A lot of that is what we would look at. A lot in lean manufacturing is trying to eliminate waste, but that would help us move towards our capacity. And that difference between the peak and the valley there is the Mura. This is the information that we can look at to see how we can best make decisions about what is working and what needs to be improved in the actual process. And so by looking at a specific area that you would like to change, obviously we need to be able to measure that to be able to change for that. And so by doing this, this gives us the visibility to actually look at what type of data that we can capture to help us make really good informed decisions about what it is we want to change or what we think might be the results of a good system. And with that, that's going to give us a better process in there and help us to receive a better ROI on our equipment and our process. And so when it comes to benefits of actually capturing fastening data, if we have that ability to record and store the torque and fastening data, this gives us a real ability to help to reduce waste. We could possibly see where, again, we may be overburdened with where a certain area may be a bottleneck in the actual fastening process. We can also, again, help to reduce waste by making sure that all the fasteners get torqued, that they get torqued correctly to help eliminate, again, any type of rework that might be needed or scrap that might be done, because we have the ability to get information directly at the time when the system is being used to help alert the operator that there is an issue. So all of this gives us the ability to make data-driven decisions regarding the actual assembly and its process. Again, this then gives us the ability to have a faster response time to issues. When we see that there might be a problem, we can go ahead and we can take care of that right away, improving our process and then providing new process benchmarks that we can look at again and see if there can be any other refining to kind of optimize the actual process. And typically optimization doesn't necessarily mean faster, but basically we're looking at how best we can use the process that we have to help get us closer to that dotted capacity line. Now, as quality control kind of can be a certain part of this as well, with production data that we're getting, this gives us the ability, as I mentioned, to correct errors before they become a problem down the line. So we can catch them when they happen, go ahead and correct them, and then move forward. And this really helps to mitigate any type of product defect that we would see that would be related to fastening. Again, so now all of this information and the fastening data that we would be getting do provide us with production records. Now, depending on the type of DC tool that you might be using, we do have the ability to link a specific record to a specific part or a specific time or operator. And all of this information gives us the ability to provide those records to whether it be a customer that is going to require fastening data. It also could be done through the use of ISO audit. So if you are looking for continuous improvement material, this could be used in that. Or it could be information that you want to have just for liability reasons, to be able to validate that this product was fastened at this torque, this day, at this time. And so all of that production information allows you to link those records to a specific build, a specific part, or again to a specific operator, and things of that nature within the actual production records that you have. Now that's going to lead us to our poll question for today. So let's go ahead and launch that poll. And so in your organizations, what are the key reasons that you need to be able to record fastening data for that? So we'll give you a couple, about a minute or so to answer that question. And we're looking at either the internal quality requirements or maybe government compliance, the process and productivity data analytics, data records for a quality audit for customers, the equipment history, or predictive tool maintenance. So let's go ahead and give you just a minute or so to answer those questions, and right back. All right, a few more answers coming in here, but it looks like the overall was data records for quality audits by your customers, along with the internal quality requirements. And so let's talk about a little bit about smart torque control systems and DC tools, but you can also be able to get fastening data if you don't necessarily have a DC type of tool. This can be done with the use of a torque analyzer and a rotary torque sensor. Now the torque sensor goes in between your tool and your part and is then connected to the torque analyzer. And this gives you the ability to actually measure what is happening with your tool on your part, and you can capture data that way. Now, it's not going to be a complete or better picture of what might be happening during the production, but you still can get that time date stamped readings of what may be happening. And again, this can be used on a hand tool, could be used on an electric clutch type of tool, any tool basically that would allow you to do that. A wrench, click wrench, you can use this type of system to be able to capture that data. That also could be used for auditing purposes, and you could be validating the tool as well. So there are multiple reasons why you might be able to use this type of system to do that. But that would be one way that you can do that without necessarily having a smart torque system or a DC type of tool. But let's take a closer look at our DC control tool, where we can get a lot of the information about what we can get with our data, and go over some of that for you as well. Our EC systems can be either a current control version or a transducerized type of tool. The difference is a transducerized tool has a built-in sensor in it that is measuring the torque as it is being provided. This is going to ensure our torque control. And then with our real-time monitoring, you're going to get a lot of the data that happens from once the trigger is pulled until the assembly is complete. This does allow for integration line control. So again, if you are communicating with a PLC or using an MES system to maybe pull up a certain preset to be used, capture that information, send that back to the MES system, that can be done all within this process of collecting and recording the data that can be streamed out to those types of data collection devices. Now, what type of data can we get from these or from our system? Well, we will be able to see what the preset torque value was that was being used. We'll get the final torque value that was achieved during that rundown. We'll also be able to integrate a barcode scanner to the controller itself. And this can do a couple of different things. First, the barcode scan can be put into the data field, meaning that if you have a part that you are scanning, that part number goes into the data stream, and it will remain there until another barcode is scanned or the system gets powered off. But this gives you the ability to actually scan a component, put that information into the data field, and now you have a complete way to track that part as it moves through the different operations as it relates to fastening for the use of our EC DC control tools. Now, the barcode scanner can also be used to pull up a certain preset that needs to be used. Or we also have another feature that allows you to create an actual assembly process for that particular build within the assembly. And by scanning that barcode, it can automatically pull up the presets or model, which is what we would call the assembly process. And it will capture all of that information and be sent again into the data stream. Now, if that barcode does have some unique identifiers in it, so say the last 4 digits are a specific serial number code, but everything else remains the same, we can tell the barcode just read the first digits of the code and disregard the last 4 digits, and it will then categorize that for that particular model or assembly process. So the barcode does give us really good flexibility in the way that it's being used and the way that it's capturing the data that it's being sent. Now, you'll also be able to get the time and date of a specific event that may be happening. And this can be helpful if you want to compare results between different shifts, or you may want to look at the results of what may be happening with a particular operator or a particular group of operators in a certain time period. So all of that gives you that ability to do some analyzing there, but you're also getting when that process was done, again, for any type of validation or documentation that would be needed. We also get the total amount of angle that happens during that rundown. And by angle, that's basically meaning the degrees of rotation that happen during that particular fastening. And this can be very helpful if we are looking to mitigate against any type of cross thread type of event, or if we are looking at a washer stack that might be missing. And we'll take a look at that in our demo process. But that angle does give us the ability to have another data point that we can look at. We do have two different protocols that we can use to communicate with, either a Modbus protocol or open protocol. And then they're also for someone that may just maybe doesn't have an MES system, but they still want to capture that data and look at it on a periodic basis. We do have an onboard SD card that can be used with the system that can capture all that data. That card then obviously can be, the information on there can be downloaded, and the card can be put back in the unit. Now, in some cases, we have some customers that an SD card is not allowed in a facility or on the floor of production. So the system can function without that, but that is another option that we have to be able to use an SD card to be able to gather the fastening data that you might be looking for. Now, there is another way that we can access information directly to from the tool, and that's going to be through the use of our software. And we'll show you that in the demonstration part of today's presentation. But if the system does, or you put the system on your internal network, you can access that controller through your PC on your network and go in and you can capture and look at data in real time. If you want to look at some graphing of what might be happening on a particular joint, you can do that as well. And we'll show that in the demonstration. But if you don't have the software loaded on a particular machine, you can still access the tool because each of our controllers has a built-in web server. So you would be able to access the controller and the information on it through a web browser on your network. So that's a really a nice feature for you to be able to access the system remotely if it is on the network. Now, our software comes free with the unit, so there is no licensing seats that are needed, no yearly subscription or anything like that. We provide that to you at no charge, just for your information there. And so let's go ahead and move to our demo for today. And I'll be looking at our EC product. And so we've got a thread block here. I have our tool, and then we have the controller here. Basically, this is just our regular controller, but what we'll be looking at is some of the data that we can get from here. So let's go ahead and jump into our software. So I have the controller connected to our software, or not connected at the moment, but we'll go ahead and connect it here. But this is our Mountz software that does allow you to be able to access multiple tools. It is does give you the ability to have admin rights and things like that, where if you have a user that wants to just look at information, you can do that without changing anything. But nevertheless, so I have our EC5000 here. I can just go ahead and connect to that. And down here, it does show us that we are connected to the unit. If we want to look at the fastening parameters that we have set, we can do that here in our parameters menu. We can open up our fastening tab. And then this gives us all of the information as it is regarded in regards to all of our presets that we have for the tool itself. So if we look at preset 1, we're set here at 2.85 inch-pounds. If I want to make a change to that, so if I come in here to preset 2 and I want to make this 3.5, I can go ahead, oops. I can go ahead and make that change, and it makes it instantaneously on the controller to do that here. But we're not here to talk about programming. We're here to talk about monitoring. So let's go ahead and look at our monitoring tab. And here in the monitoring tab, we've got a couple different things that we can look at. First, we can go ahead and if we want to do some type of diagnosis as it relates to any type of joint characteristics on a certain fastener. Let's see, let's move this up just a little bit. But we're going to get all of the data information from this as well. We do have the ability to monitor a couple different channels. So torque obviously is one that we want to look at. And then we also have the ability to look at either the current, the speed, angle, and some other items. But let's go ahead and look at the total angle. Yeah, let's do that. And we can go ahead and hit start. And so now, if I run the tool down, we're going to get a graph that's generated from what the system sees. Now, we are also getting the data from that particular rundown as well. So we have our time and date. We have the things that we're monitoring, our torque and our angle. We have our what would be our sampling rate. And then we have our fastening time here in milliseconds. Then we have our actual torque value. And then we have our completed torque, which was set at 2.85. We achieved 2.88 at our RPM speed of 600. And then we had our angle or what was run in. So we have two angle measurements. We have angle 1 and angle 2. Angle 1 is the free speed portion of the rundown. And so when the fastener reaches a certain seating point, it will start measuring that torque value here. And you can kind of see that within the graph. So as the system reaches from the snug angle to its final angle, that is just 5 degrees of rotation versus the 1300 or so degrees. But if we add up these two numbers, that's our total angle degree. And we can continue to do that with different rundowns, and we can capture all of that data and those graphs. If we want to have this auto saved, we can click on here, and this will automatically save the graphs as it relates to the particular rundown. If we want to go back and we want to review a graph, we can do that. And so you can see what might be happening on those particular areas. Now, what also might be helpful is if I go ahead and run down this particular fastener. So this one, you can see the curve is a little bit different. It's a little bit higher here, and then we get a more gradual run up to the final torque. And that's because this is a soft joint, and that can be shown here by the amount of the angle 2 that we see compared to 5 degrees of angle from the seating point to 156 degrees of angle from the seating point. And that's because we have a washer stack on there that is a very soft gaskety type joint. And so if we were looking at data from a particular process, and that process included a soft joint like this, and we looked at the data and we saw that our angle 2 data is only 5 degrees instead of being 100 plus degrees, we would know that their washer stack for that particular fastening was not present. And so that would be one way that we could use the data to look at that particular setup, and that depending on what other types of requirements you might be looking at, there are different ways to be able to use the data for sure. That way, this is one way to do that within using the real-time graph function for that. This can also be very helpful if you have a joint that may have some prevailing torque and you want to see what might be happening with that, or you want to do an audit for some fasteners that you may have and you want to see what's happening during the rundown of those fasteners. That is possible to do that as well with these. But let's go ahead and stop this for now. We'll come back up to our monitoring tab here, and let's click on real-time monitoring. And so the real-time monitoring gives us the data that we would see. Again, very similar to what we just saw with the graph, but it's going to give us a little bit more than that. What's added is our total degree of angle here, along with our barcode, if that gets put in there. And then also our status, if there was an error, what that error was, or the error code for that. But if we go ahead and start this, what you'll see is an event that happens is recorded. And now what this event was, I put the tool into the reverse direction, and I went ahead and reversed up a fastener, and it's capturing that information as well. So it's getting all of the event data that happens, unless we want to turn off that particular event. But nevertheless, we do we can see what direction the drive is running. And in this rundown, we have, again, our fastening time in milliseconds, our target torque, what the final torque was. And then here we have our snug angle and our A3, or our angle 3, which is basically just A1 and A2 added together. But that gives you all of the total angle. Again, if we had a barcode that we were using, it would show up in this field as well. And so if we continue to run the tool and we're capturing data, obviously in a production environment, you would not necessarily have the tool being used with it being in reverse like that. But nevertheless, this is going to give you that information as a snapshot. And then again, that information can be then parsed and looked at, assigned to, again, used through either Modbus, Open Protocol, to be able to be used in your MES system. One thing else that we can do in here is we can use a process control capabilities if we want to go ahead and let's stop this and clear it. If we want to do a capability study, that is something that can be done as well. And so let me go ahead. I've got a little routine that is set up on our tool by using our multi-sequence process. Basically, it allows me to allow the tool to run down, reverse back up, pause, and then run back down again. And it does that in a cycle of 15 fasteners. So let's go ahead and run that. And if you want to do a gauge R&R type of study, or you want to capture the CP or CPK of that, we can do that, or a CMK study. If we go ahead and turn that on, we can go ahead and run this. And it is basically running through the process. And let's see here. You can see that what's going on here. And then we can see the results here after the study. So we had a very good CP and CPK number. but it's going to give us our curve that we would be able to go ahead and look at. It automatically puts in the lower limit and upper limit based off of the preset value that you're looking for with your standard deviation. So this type of information does allow you then to look at the tool specifically, but the other information allows you to look at what's happening during the fastening process for that. And so with that, that's going to wrap up today's session. Gives us time for any questions that you might have. We can try to address those. And for today, we have Ashley. So, Ashley, do we have any questions?
Hey Dave, just a few. First one, what is the difference between a transducerized and non-transducerized tool?
So, a transducerized tool has a built-in sensor in it that will give you, that's actually measuring the torque value that the tool produces. A current control version tool acts very similarly, except it uses the current that is being drawn from the tool that is correlated to the torque output of that. So the transducerized tool has a measurement device in it. The current control does not, but that does not necessarily make the current control version less accurate. It just helps to reduce the cost of that item, but it does help, or it can also provide the output that you would need to be able to validate the torque that you would be getting, along with all of the other data factors that we're getting.
Okay. How many workflow or fastening sequences can be programmed and stored with this system?
So if we're looking at storing data on the controller, I think we tried to calculate it through the SD card. It's just a standard SD card. So based off of whether it's an 8 GB or 16-bit or gigabyte card, you could store, I think it was 3 years of data without looking at it. But nevertheless, that is possible to pull that off periodically. If we're looking at the amount of uh, values or that relate to the system itself, it does currently have 15 presets. We can also take those presets and create 15 models or 15 assembly processes that would be used of those 15 presets. And so that would be the capacity for the actual torquing of the tools.
Okay. Can you measure running torque with the system?
You can measure what would be a prevailing torque. So you could set a fastener to run a specific degrees of angle or rotation. So we're just, if you want to look at what the value is for the running torque, you can do that. We also have the ability with the another model that can compensate for that prevailing or that running torque. So it will take a look at what that value is, and then it will add whatever the preset torque value is for that preset. So it's going to give you a higher value than the preset because it's actually accounting for any type of prevailing torque. And that's because we want to make sure we're getting the correct amount of tension on the fastener, because if there is some of that torque that's being used by the prevailing torque, then we're not getting the full stretch that we might be looking for that particular fastener. We also have the ability to measure what the actual clamp force is when the system begins to seat. So we can take that value and then add whatever preset is there in there. So that would be considered either a prevailing torque mode or a clamp force mode. And that is available on our transducerized plus version tools. So yes, we can do that.
Okay. Is this software compatible with the LTT and can it be used efficiently when calibrating a high volume of torque drivers per day?
Uh, So the LTT software stands alone, and then the unit. Obviously, you can use the tool on an LTT and capture information that way, but they don't necessarily talk to each other that way. Unfortunately, that doesn't work that way right now. But maybe here in the future, we'll have that capability.
Okay. Can this system be programmed and used for thread tapping applications?
Yes, you can use those for thread tapping. We do have as I mentioned when we were talking about prevailing torque, we do have the ability to either use a fastening strategy that would rely on torque, or we can use a fastening strategy that relies on the amount of turn or angle that happens. And so, if you do have a tapping application, you want to run a tap down and then pull it back up. We can do that through the use of a couple different settings, but that is possible to do for sure with the system.
All right, that's it for questions.
All right. I want to say thanks very much for joining us today. I hope everyone has a good holiday season, and we look forward to seeing you again in our next webinar next year. Thanks so much, and have a great day.